Good day everyone, I am Hannah A. Domingo and I will be reporting project scheduling. First, let us know what is resource allocations for design. Efficient utilization of resources is critical to successful management. The primary resource during design is the work hours of the design team. So this means that the project manager depends on the design team to create design alternatives, produce drawings, and write a specification for the proposed project. To properly coordinate all aspects of the design effort, the project manager must ensure the correct expertise is available when needed. Generally, design team members are assigned to the project by their respective home departments. Since, since each designer is often involved in several projects at the same time, the project manager must develop a resource allocation plan for each project. The plan should then be distributed to each design team member's home department to ensure that each resource will be available when needed. The project manager can resource load the project plan to include the number of work hours required for each design discipline. This is necessary to ensure adequate resources are available for the project when required. The resource plan is simply a histogram of work hours versus time for each design discipline. The project manager should provide the resource plan for each project to the design team's manager. The design manager can then integrate the resource plan of all active projects into their department's demand for technical expertise. Next is resource allocations for construction. During the construction phase, the primary resource are labor, materials, and equipment. The correct quantity and quality of materials must be ordered and delivered to the job site at the right time to ensure efficiency of labor. Equipment to be installed in the project often requires a long lead time from the fabricator. Thus, the project plan should include material and equipment required by the construction workforce. Labor represents a major cost of construction. The labor force on the job operates construction equipment and installs the materials. A resource allocation plan is required to ensure high efficiency and productivity during construction. The project manager can resource load the project plan to include the number of work hours required for each craft of construction labor. The resource plan is a histogram of work hours versus time similar to the cost distribution analysis. The construction plan shows the desired sequence of work. However, to be workable, the plan must also show the distribution of resources such as required labor for each craft on the job. The demand for labor should be uniformly distributed for each craft on the project to prevent irregularities. Next is the Program Evaluation and Review Technique or PERT. In the critical path method of scheduling projects, the duration of each activity is usually defined with a reasonable degree of certainty. For most projects, the type and amount of work is known, which enables the project manager to establish the approximate duration for each work activity. Using the CPM, the assignment of one duration to each activity provides a deterministic process for the start and finish dates of each activity in single dates for the entire project. For example, the time to produce drawings may be 4 weeks, the time to perform the soil investigation to gather the test soil sample may be 2 weeks, or the time to erect form for concrete may be 3 days. Next, the program evaluation and review technique or PERT method of scheduling uses the duration for each activity and the fundamental statistics to determine the probability of the project finishing earlier or later than expected. The PERT method uses an arrow network diagram to show the logical sequence of activities in the project, whereas the CPM uses the precedence diagram. Although the PERT method is not used extensively in engineering and construction projects, it provides valuable information for assessing the risk of the schedule slippage of the project. The major difference between the PERT method and CPM is the estimation of durations of activities. Using the PERT, there are three durations that are assigned to each activity. A is optimistic time, B pessimistic time, M most likely time. The optimis the optimistic time is the shortest possible time in which the activity could possibly be completed. Assuming that everything goes well, there is only a very small chance of completing the activity in less than this time. The pessimistic time is the longest time the activity could ever require. Assuming that everything goes poorly, there is only a very small chance of expecting this activity to exceed this time. The most likely time is the time the activity could be accomplished. If it could be repeated many times under exactly the same condition, it is the time that it would take more often than any other time. The most likely time is the time the manager will probably give if as for a single time estimate. It is important to note that the optimistic time and the pessimistic time may not deviate the same amount from the most likely time. In simple mathematical terms, A and B may not be symmetrical about M. In this slide, it shows a table of irregular distribution of labor. Here also. Next table is the distribution of labor after starting activity F 2 days later than the activity H 2 days earlier. PERT uses a weighted average of 3 times to find the overall project duration. This average is called the expected time or DE and is found by the following simple equation. So here is the formula for to get the uh, average, which is expected time equals to uh, optimistic time plus form most likely time or M plus B, which is the pessimistic time over 6, where TE is the expected time of an activity. The above equation is used to calculate single duration for each activity in the PERT network diagram. Next slide is to determine the probability of the project completing earlier or later than expected using PERT. The variance of the activity along the critical path must be calculated. The variance of an activity is the square of the standard deviation of the activity and can be calculated using the following equation. So here is the equation where V is the variance of an activity. Next, if we want to get the standard deviation of the expected time, we should use the a formula at the top. The final calculation necessary to perform PERT calculation is the deviation, which is denoted by the symbol z in the following equation. This equation, where the z is the deviation. Next slide shows the PERT probability table. Table 8 to 6 provides the value of z for various probabilities of certainty, and the term T is the expected time of the event, which is calculated from the PERT diagram, and Ts is the scheduled time. So using all the formula kanina, ito yung makukuha mo. So next slide, the following is the graphical plot of the probability versus the project duration. This curve provides the full range of probabilities for assessing the risk of finishing the project ahead or behind the expected duration of 81.3 days. So using all the formula presented kanina, makukuha mo itong 81.3 days. Actually, this is an example, pero ang pinakita ko na lang is the table. But using all those formula, makukuha mo itong 81.3 days. And this analysis is based on a optimistic time for event 15 based on the critical path activities. A full analysis is more complex if all near-critical paths are analyzed. For example, this is possible to have another path through the PERT diagram that is near-critical, which would yield to a shorter expected time for event 15 and the higher value for optimistic time due to larger variance in the activity in the non-critical path. So that's all. Thank you.